Hi geometry students, this is Mrs. Turner, and this video is going to start off our new chapter for us, which is all about triangle congruence. And so this first section is actually 4.2, so we're skipping 4.1 in case you noticed. In this first section, we're just going to be introducing ourselves to different types of triangles, kind of learning some different names of the different triangles, and using that to find missing angle measurements and side lengths. All right, so let's jump into this here. So you will need your 4-2 guided notes and something to write with. And just like any video, feel free to pause it. So there might be some times where I'm going a little bit fast, but you can certainly just pause, take your notes, hit play when you're ready. You can also go back and rewatch it if you're confused about something. So that's kind of the nice thing about having this video. All right, so our first term here is for triangle. So what is a triangle? It is a polygon with 3 sides. So on your notes, you have a triangle, and you can see the 3 sides are 3 line segments. So you have segment AC is one side, segment AB is another, and segment BC is the third. So those 3 segments make up the 3 sides to the triangle. And then also, well, what happens when you have a triangle is you also get 3 different angles. You've got angle A, angle B, angle C. So those points A, B, and C, those are the triangle's vertices. Okay, they're each a different vertex for those 3 different angles. And if you think about the word triangle, tri, the prefix meaning 3, and then angle. So a triangle is a shape with 3 sides and 3 angles. And I want us to take a little bit notes here about the notation, or how do we write the name of a triangle. So we draw a little triangle symbol, and then you name the 3 vertices. So for example, this is triangle ABC. So you always start with a little triangle symbol, and then the 3 capital letters, those are the 3 vertices of the triangle. And order doesn't matter, so you could also start with B, and then you could go and say that this is triangle BCA, or you could go triangle BAC, okay, or you can start with vertex C, and you could name this triangle CBA. All right, so order doesn't matter, but typically we go in alphabetical order. All right, there's 4 different types of classifications based on the angle measures. Okay, so the first one is an acute triangle. And so the space underneath the triangle, you want to write this down, that it has 3 acute angles. And remember what acute means? It's an angle measure that is less than 90 degrees. Okay, so in an acute triangle, it's going to have 3 angles that are less than 90 degrees. All right, the next one is equiangular triangle. And this is a triangle that has 3 congruent acute angles. And if you know anything about triangles, you may know that all 3 angles add up to 180. So if we do a little simple math problem here, if we know that all 3 add up to 180, but they're all congruent, or they're all equal to each other, then if you do 180 divided up into 3 equal angles, then that means each angle is 60 degrees. Okay, so that's just a little extra info there for you. And that is true about every equiangular triangle. All right. Next triangle, right triangle, is going to be a triangle that has 1 right angle. And then an obtuse triangle is going to be a triangle that has 1 obtuse angle, which, if you remember, an obtuse angle is an angle that is greater than 90, but less than 180. So it's any angle between 90 degrees, and 180 degrees. So an obtuse triangle has one obtuse angle, and then the other two would be acute. All right, so let's practice classifying by its angle measure. So the first triangle that we're looking for in here is EHG. So we've got a couple, actually 3 different triangles here. So let's first identify where triangle EHG is. So if we trace out EHG, okay, that's this big triangle here, and look at the 3 angle measurements at vertex E, which is 30, vertex H, which is 90, and vertex G, which is 60. And so because we have that right angle at H, this would be a right triangle. Okay. All right, the next one is triangle EFH. So let's start over and identify where triangle EFH is. So if we trace that out, so EFH. Okay, we've got at vertex E is 30 degrees. Now vertex H is this just smaller angle here, it's 30 degrees. And then F, we don't have, but what do you notice about the relationship between this angle here at F and then 60 degrees over here? Well, those two form a linear pair. So it's 120 degrees is that angle F for triangle EFH. So because you have that obtuse angle, angle EFH is an obtuse triangle. Okay. All right, last one, triangle FHG. All right, so let's identify where FHG is. So that would be this triangle, FHG. Over here on the right, we've got at vertex F, we've got a 60-degree angle. G is 60 degrees. And then up here at H, we don't know, but we have a right angle up here that's split into 30 and this angle. So if we do 90 minus 30, that means vertex H is 60 degrees. So because all 3 are 60 degrees, they're all congruent acute, then that means it is equiangular. Okay, now we're going to look at classifying triangles based on side lengths. So the first one is equilateral. So again, underneath you can write the description, which is that it has 3 congruent sides. So you can see that in the diagram there by those 3 congruent tick marks. Okay, equilateral, 3 congruent sides. The next one, isosceles, has at least 2 congruent sides. And then scalene is the third one. And notice there's no congruent markings, so it has no congruent sides. It's going to have every side a different length. All right, so let's classify triangles now based on their side length. So the first one is triangle ABC. So if we trace ABC, we got that triangle there. So AB is 15. And notice the congruent markings. So AB is also congruent to AC. So AC is also 15. And then BC is also 15. So if all 3 are the same, oops, can't write with my highlighter here. Let me switch to pen. So if all 3 are the same, then it is equilateral triangle. Okay. All right, next one. triangle ABD. So let's start over and identify triangle ABD. So AB is 15, BD 80, so AB 15. Now notice BD we have to combine, so 15 plus 5, so that side length is 20. And then AD is 18. So 15, 18, 20, they're all different, so that would be a scalene triangle. All right, then our last one, triangle ACD. So ACD, this small triangle over here. So we've got AD is 18, CD is 5, and then AC is 15 from before when we had the congruent tick marks. So 15, 18, 5. Again, all three are different. So that's another scalene triangle. All right, so let's use our classifications to find side lengths. So here we have a triangle, JLK. Can you see what kind of triangle it is? We've got congruent tick marks here, so JK and LK are congruent. So in terms of setting up an equation, we can then set those two side lengths equal to each other so that we can solve for x. So 4x minus 1.3 equals x plus 3.2. So we're setting JK equal to KL, and then we can solve for x. So subtract x from both sides. So I get 3x minus 1.3 equals 3.2. And then add 1.3. So we get 3x equals 4.5. Divide by 3. We get x equals 1.5. So then to find the side lengths, we can take 1.5 and plug it back in for x. So the length of JL, okay, so that is up here, 5x minus 0.2. So 5, and then substitute in 1.5. So 5 times 1.5 is 7.5 minus 0.2 is 7.3. All right, then we can do the same thing for LK. So that we're looking here, x plus 3.2. So substitute in 1.5 plus 3.2. So that gives us 4.7. And then because JK is congruent to LK, we should also technically get JK 4.7, but I like to plug it in just to check. It's a good way to check to make sure that you solve for x correctly. So 4 times 1.5 minus 1.3. So you get 6 minus 1.3, which sure enough, you get 4.7. So that looks good. All right. This is not on your notes, but just want you to kind of put your pencil down and just kind of do a quick little triangle review before we do our last example. So can we go through and classify each triangle by its angle measures? So the first one, I'll do this one here. We've got a right angle. So this is a right triangle. Okay, how about the next one? What do you think? 136, right? That's an obtuse angle. So this is an obtuse triangle. And then how about the last one? Well, we've got 60, 60, 60. All three are congruent angles. So this is equiangular. Okay, how'd you do? All right, let's do a couple more, just fill in the blank here. An isosceles triangle has how many congruent sides? It's at least 2. What kind of triangle has 3 congruent sides? That'd be equilateral. And then what kind of triangle has no congruent sides? That would be scalene. All right, hopefully you tried those out with me. Hopefully you got them right. All right, but let's move on to our last example. So it says find the side lengths of equilateral triangle FGH. So equilateral means all 3 sides are congruent. So when it comes to setting up an equation, it does not matter which 2 you set equal to each other. Okay, congruent means equal, so pick any 2, set them equal to each other. I'm going to go with FG and GH. So I'm going to set 3y minus 4 equal to 2y plus 3. And this is a nice equation here, so I can subtract 2y from both sides. So I get y minus 4 equals 3. And then add 4 to both sides, I get y equals 7. And then again, I'm going to plug it back in so that I can find my side lengths. So if I first plug in for FG, so that's 3 times y minus 4. So 3 times 7, 21 minus 4, and we get 17 for FG. And then again, technically I should get 17 for all of them, but let's just double check. Because if you accidentally solved and got the wrong value for y, then you would not get all 3 equal. So that would be an indicator that you need to go back and check your work. So GH, if I plug 7 in, so 2 times 7, 14, plus 3, 17. Yep, so that works. And then the last side, FH, 5 times 7 is 35, minus 18. Yep, got 17 again. So all 3 sides are 17, which looks good since it's equilateral. Okay. All right, so that's the last example on the notes. Hopefully you took all of your notes, and next class you want to bring these with you and make sure you have a good understanding. Make sure you bring any questions that you have to class. So we're just going to be doing a little bit of review of this and kind of working more with these different types of triangles.